Okay, now we are dealing with simultaneous equations. We shall look at question part A first. Okay, if you look at question part A, we have two indices equation. The first one is 2x minus 5y equals to 3, which is one indices equation. The other one is also indices equation. All right. The idea behind solving simultaneous equation is also similar to solving another equation, all right, which is actually we have to use substitution if needed. Okay, so let's look at one by one. For the first equation, we have 2x minus 5 equals to 3. Okay, this is one equation. There's no other way to simplify this equation because 2x is a standalone term and then 5y is also a standalone term. Alright, there's no way we can combine these two indices as well. But if you look at the second equation, I have 2x to the power of minus 3, x minus 3, and then equals to 21 minus 5 to y minus 2. Okay, the index are different, okay, because the index of the second equation for 2 is x minus 3, and in the first equation I have 2x. Okay, we can always split x minus 3 because I can rewrite it into 2x times 2 to negative 3. Okay, in the same way I can also split 5 to the power of y minus 2. So I have 5 to y times 5 to the power of negative 2. Alright, if you look carefully, 2 to negative 3 is just 1 over 2 cubed, which is 1 over 8. So 1 over 8, 2 to x equals to 21 minus, now 5 to negative 2 is 1 over 25, 5 to y. Alright, now what is commonalities with the first equation? Let me label it second equation. The first equation have equation in terms of 2 to x and 5 to y. Okay, the second equation is also another equation in terms of 2 to x and 5 to y. So this suggests us something. So if I let u be 2 to x and then v be 5 to y, right? I can rewrite the equation. The first equation become u minus v equals to 3. Alright. The second equation become 1 over 8u equals to 21 minus 1 over 25v. Okay, this is the first and this is the second. What do you observe here? You'll see that this one is just a pair of two simultaneous equations which are linear. Alright, something that we can solve using our normal method that you have learned before, and from there you'll be able to solve for u and v, and after that you can solve for x and y. Okay, please try it. In the same way, we can also now analyze b. Okay, in b, right, there are two equations. One thing that you notice, the second equation here is already a linear equation. Okay, linear in x and y. Alright, so basically we don't need to do anything to the second equation because it's already something that we can deal with easily. So just look at the first one. Okay, let me call this equation 1 and this one equation 2. Alright, so from equation 1, I have log base 2 of x plus 2 log base 4 of y equals to 4. The same method applies. Alright, you have to analyze the base first. They are of different base. So the very first step is to change to the common base. Okay, the common base is base 2. So I change to log base 2 of y over log base 2 of 4 equals to 4. Okay, notice that log base 2 of 4 equals to 2. Let me write on the right. The reason is because log base 2 of 4 equals to log base 2 of 2 square. Alright, and by the third law of indices, the power law, you can bring this to the coefficient, become 2 log base 2 of 2, and this is equals to 1. Alright, so log base 2 of 4 equals to 2. Because of that, I can cancel this term. So left with just log base 2 of x plus log base 2 of y equals to 4. Okay, These two terms can be combined, right? I can write as log base 2 of x times y equals to 4. Okay, with a simple conversion, I get x to y is just 2 to 4, which is just 16. Alright, so you notice that solving this system B, right, is the same as solving, let me write in the middle, 7x minus y equals to 6. First, this will be second equation. And the first equation now is transformed into xy equals to 16, which is something that you have learned before in Sec 2 as well. Alright, this is a non-linear equation, but it can be solved. Alright, and the method is always to start from the linear one, okay, and then use substitution. For example, you can express y in terms of x or x in terms of y, substitute to the second equation, then you will be able to get one equation with one unknown. Alright, then you can solve it and you can find the other unknown. Okay, please try.